Thank you, everybody. Thank you for being part of Tech Unplugged here in Austin. I'm Stephen Foskett. I am a storage blogger. You can find me at blog.foskets.net. And also, I have a little thing called Tech Field Day that I do. And you can find that at techfieldday.com. So, since I talk about storage a lot, Enrico wanted me to do a little bit of a future of storage panel. And just to set the stage, I'm actually have a half-written blog post sitting back there that I haven't pressed publish. I meant to publish it before we started this session, but you know, stuff. And you know, if you don't know, storage is in the midst of a fantastic transformation right now. We have flash memory that has the promise to really radically change system architecture, not just storage system architecture, but system architecture, because it offers tremendous benefits in terms of power, space, and of course, performance. But so far, we haven't really lived up to the promise of flash memory, even though we're continually pushing it forward. There's 3D, there's Crosspoint, there's all sorts of technology coming that promises even better performance, capacity, price, physical size. The question is, how do we use that stuff? How do we actually make a transformation of the entire industry, not just, or the whole stack, not just the storage stack? And so that's kind of the question that I'm posing to the folks up here. What are we going to do with this newfound storage goodness? And Eric is grinning the most, so I'm gonna go to you first. Also because I know a little thing about what you're planning on doing with this. So go ahead, yeah.
Wow, what are we going to do? I don't know exactly how to answer that question. We at Hedvig, we kind of live in this software-defined space, and I'll talk a little bit about that later this afternoon. But you know, I don't think we could exist without the help of flash and SSD memory, which sort of helps reduce the latency and provide the performance that's really needed when you start trying to do something that's purely based on software that's distributed. And I think you know, we recommend all of our customers have it in multiple layers so that we can move data in and out and leverage it.
So your approach is to have a real integrated, sort of a hybrid system, where flash is a core component of a greater system.
Yeah, exactly. So you know, hard drive is still hard to beat in terms of the capacity that it provides, but in order to get the performance, we like to have sort of a tier of that flash disk, if you will.
And Dennis may have a different idea.
Right. So we're the position that basically the disk is going to go away eventually. And the reason for that, number one, we're talking about scalability. We're already seeing pure flash arrays scaling up to petabytes. So the capacity issue is kind of going away. Cost was always an issue. It always has been a serious issue where disk is a much better economical alternative. However, that's coming down as well. With the introduction of the new technologies that are available to flash storage, such as deduplication, the cost per gigabyte is starting to drop down into the mainstream price of the high-end disk arrays. So I think we're seeing a transition to, eventually to all flash type of arrays, which fits perfectly when you think about it with the utilization of SDN. Because with an all-flash array that exposes itself, say through REST APIs or others, to SDN, I think we can actually find ourselves moving into an all-silicon data center.
Okay, so an all-flash storage layer. And of course, NetApp, you know, you guys have all flash and all disk and everything in between.
Yeah, I think the direction we really see the market going in is flash is definitely taking adoptions. We're almost seeing the death of SAS drives has already happened. So certainly flash is primarily taking over the data center. If you have the ability to do deduplication and compression already in your storage tiers, you're way, way ahead of the game. A lot of the arrays that can't do dedupe and compression or already can't cost effectively use it. But we're already seeing larger and larger and higher capacity drives, the 3.84 terabyte TLCs, for example. We've got 16 terabyte TLCs are coming. We see, honestly, the death of SAS has already happened. The death of SATAs is right around the corner. And now it's going to become a question of, you're going to get performance, but you're going to start to, especially with those 16 terabyte drives, you're going to start to see the data densities become similar as you factor in dedupe and compression on top of that. So we're seeing that it's going to become much more of a data management. You'll be able to put, you know, large capacity 3D Crosspoint's going to be potentially in servers. It's going to be in the storage layer, but we're also going to need to manage that data through its life cycle. NAS protocol access methods, SAN protocol access methods, and then eventually the hybrid cloud. But we think that's where storage is going to go. You're going to use flash as a media, but we're going to have different sizes and different densities, just as we have with traditional spinning media. But it's going to be much, much faster, much more scalable. It's going to be much more cost effective.
So guys over here who don't have a horse in this game. What do you think? Who wants to jump first? Justin?
I can jump. Largely, don't care. It's interesting when people say flash will replace disk, and say, yeah, it will, when the economics make sense. In the same way that we use faster, like the 15K RPM disk instead of 10K RPM or 7200 RPM. It's another option that we have. But the whole reason we have storage is because memory costs too much. That's all it's for. I'm really interested in, I'll get really, really interested when we start having software written to use persistent memory instead of non-persistent memory. Whereas at the moment, all software is written to say, well, basically we have memory, which is stuff that we're working on right now, and then we write everything out to a storage device of some sort if we want to keep it. If we have something which is fast enough, 3D cross-point memory and that sort of stuff, maybe memristors if that ever actually happens. If that gets fast enough and cheap enough, then we might start to see that kind of radical change in the way software is written, that's what I would call a real game changer. Everything else is just incremental development of okay, we've got some faster access media, awesome.
Yeah, I completely agree. I feel like we're still living in sort of the Flash 1.0 world where we're using Flash purely as storage, better storage, phenomenally better storage, but as storage. What about when will the system architecture change? You're saying you need software, we need hardware too. Do you want to talk about that, Arjan?
Surely we need hardware too, but we need to educate the customers also to make sure they make the right decisions at this time, going towards an all-flash data center or whatever it will be. So I think it's, if you ask how are we going to use flash in the data center, it's also about educating the customers going the right way. And I think a lot of the vendors have a certain point of view of what they are willing to sell at the moment and helping the customers going towards something that is the future for them, helping them get there.
So for the storage folks here on stage, essentially I'm with Justin. I believe that we are looking at something that goes beyond just making a better storage array. How do you guys fit in this world of beyond a better storage array and into a better system, a better compute system?
If we take a look at, as an example, I don't know if folks here are familiar with OpenStack. OpenStack is one of the driving forces behind OpenStack is to reduce the cost in the data center. And of course, we're trying to do the same thing in the storage end, but take a look at what we can do in the industry now. So you're seeing all the industry players opening up their arrays to ability to go in and moderate and manage those arrays from software. We all have management packs to go into System Center Operation Manager. We support OpenStack. I'm sure pretty much everybody does through the REST API. So really, we're to the point now we're saying, well, here you go, guys. I mean, we're letting you come in and take over our array. What are you going to do next?
And I know, Eric, that you guys have talked about having a more integrated storage solution. So it's not just a thing off to the side. It's not its own little storage ghetto.
Depends on what you mean by that.
Yeah. Well, we're seeing smarter storage systems. We're seeing storage systems that are more integrated into the whole solution, the whole application.
Right. Yeah, I mean, we are trying to spend time to kind of build that glue that goes into the, from the application all the way down, whether it's OpenStack, whether it's now something like Docker and whatnot, right? To be able to, I know one of Ray's things was persistent storage on some of the slides earlier, to try and make sure that no matter what you're doing, especially with modern apps where it can be a little bit more challenging to spin up storage because you're trying to do it very fast, thousands of times a day, that we think that you really have to have much more of an awareness all the way up into the application, down into the hardware. And by the way, I do have my software-defined lens on. We don't care what that hardware is ultimately, and the faster and better it gets, the better we're going to perform.
Yeah.
And ultimately, I don't. As someone who uses storage and has spent a lot of time in the storage industry, I don't care either. Like from a developer perspective, what I want is some storage. I don't want to have to care about all of this sort of stuff. In the same way that I want some memory to do some stuff where it's like, I just want to put some storage. I don't want to care about fiber channel or NFS and whether or not you've implemented 4.1 properly or whether you pronounce it SIFs or not. Yeah. Who cares? It's like, why do I have to care that someone's put iSCSI in?
Yeah.
You know, it's like, I just want some storage. So, and I know that like they're Hedvig guys, and every time I see someone, like some of the new players, and they bring out this array and they say, well, we support all the protocols, and we'll do scale out, and we'll do this, and blah, blah, blah. It's like, I'm looking for that promise of, I just want some storage.
Yeah. Yeah. And of course, it's not just storage either. It's not just capacity. It goes way beyond capacity. It goes to, you know, performance and quality of service and flexibility and scale.
Yeah.
As well.
They're all features of the storage that I want. But largely, I want an area where I put my stuff.
Yeah.
And then I want to be able to look at it and do stuff with it. But the underlying, how that actually works, it's like, yeah, as a nerd, I kind of care, but generally, I don't care. I don't want to have to care.
Yeah, I think increasingly with what we've tried to do with our architecture all along is there's a lot of things you can do on the storage layer when you own the data. You can do, you know, very efficient snapshots, very efficient clones and replication, and that data management capability, I think the trick is to project that capability up to the software layer. Yeah. Every time I've seen those things done, and I've been in the IT industry for far longer than I'd like to admit, but every time I've seen people try to do it in software, it eventually fails for a variety of reasons. You know, now that we have software-defined storage, it still ultimately comes down to who owns the data, but giving you as many access points to that data, making it as easy to manage it through its life cycle, et cetera. We don't think that's going to change with Flash, but things like OpenStack is projecting all of the capabilities of the storage array up to the application layer, so you don't have to know how it works. You don't have to know what protocol you're accessing it. A snapshot's a snapshot, a clone's a clone, and replicating that on-prem or in the cloud should be exactly the same. But I think that's the challenge going forward, is AWS is kind of setting that point-and-click application. I just want to put my data there and use it exactly as you said.
Yeah, which is what Justin talked about this morning, and I love that aspect of it, that it's just sort of on, and you just use it, you know.
Predictable, yeah.
Yeah.
I think that's the challenge of the new storage development, is we need to make our platforms, frankly, behave like AWS on-prem.
Interesting part of that, though, is like I see a lot of discussion around AWS and cloud and containers and all this sort of stuff, new apps, and it all seems to be about the way the apps are written, and none of it's talking about the data. Yep. And you know, the whole concept, like moving data around is painful and difficult and hard and costly, and it sucks. And mostly because physics. Like there's very little that we can actually do about it until someone invents a way to travel faster than light. So one of my greatest frustrations, I think, is that people aren't really addressing that. How do I make my data available in that multi-data center type world? Because the cloud is just another data center, quite frankly. It's like, I don't care. It's over there. It's another computer, but it's over here. But if I want to do things with apps that can run up and anywhere and do all of this sort of magic container stuff, awesome. But the reason I have the app is because data, because I'm working on some sort of data with it, and I need that data to move around. And you know, I live in Australia where my internet comes to me through a piece of wet string. So
it's wet kangaroo string, but it's wet string. Yeah.
Yeah. So when things like cloud services and so on, they're not too bad, and you know, I exaggerate for effect. But when we're talking about moving large amounts of data, like you know, I run a podcast and I have audio production, and that's just audio. When I do videos of our VMUG and try to post them up, you know, uploading to YouTube, it's painful and slow, and that's a tiny use case, and that's something that I'm not seeing much activity around yet. There's some people who are looking at bits of it, but I'm not really seeing a good comprehensive answer to that question yet.
There's hope, because CERN did actually break the speed of light last week, apparently.
Really?
Well, yeah, and then they keep taking it back and saying,
Yeah, that's it.
But yeah. So Arjan, storage software, software layers. What do you think? Data software, storage software?
Both. Software is what everybody's talking about these days. So it seems that storage should do that also. And a lot of storage is already doing that. But I agree with Justin. It needs to, for a customer, in the end, it needs to provide everything they want, they need, at a cost-effective frame. And I don't really see anything at the moment that does it all. So yeah, I think there's a lot to gain from that perspective, if you look at it.
Yeah, you got to come to my speech later on today.
Yeah, there's a lot of companies talking about basically data awareness of one way or another.
So
you want to jump in? Yeah.
Yeah. So what at Violin, what we've done, we had a hardware product out for quite a while. That's fastest thing on the planet, wonderful. But people want more than that, like you said. So what we've started doing is adding in services on top of that. You got to have the services because there are people who just want a pure performance play. But when they say, well, now what do we do? Thank you, I need to do the next thing. What's the next step? So doing that in a methodology that's easy to use is finally coming to fruition, and not only our platform and others as well. The simple, easy to use user interfaces that are XML based. You pop up a browser anywhere you're at, you can do management. The question then becomes, and you brought up a good point, now that we have the ability to do that coming in our product, your product as well, how do we then encapsulate that and move it into the application stack? And that's the thing I think a lot of people are struggling with right now.
I think increasingly what you're going to find is that line of on-prem storage versus cloud storage, the data management between the two is going to become the critical factor. And flash for performance is a given at this point. It's now a data management differentiation. And then as the applications change to consume it in the AWS model, for example, there's going to be a different structure. Different access methods. We've tried to do that with our NetApp private storage and our cloud on tap, is give you the same data management feel on both sides. But I think making that more agnostic is going to be where, platform agnostic underneath the covers is what's going to make a big difference long term.
Yeah. Yeah, and I don't know if you really want to talk about any other platforms.
We may.
Okay. I hear there might be some other movement on that topic as well in terms of integrated storage. Okay. In the future. Okay, we're not going to talk about that right now. You want to jump in? How about this? I'll give you guys a softball. Who wants to tell me what software-defined storage is?
Boy, you're going to have a fist fight up here.
Okay, yeah.
Well, it's interesting.
I've got the enforcer here. I'm ready to defend.
Different answers, I think.
You might, because everyone says, well, hey, all of our stuff is in software, right? That's the intelligence. We at Hedvig, we take an approach that says, your server plus our software equals your storage system. And so we sort of deal with it in that way because, of course, through my vendor lens, I'm software only, so it works for us. And we like to carry that definition and sort of proudly carry the flag of software only. Typically these days, the definition starts to include other aspects like, well, it's software and it's scale out and it provides the ability to add new nodes and take out old nodes, and all of this is seamless and so on. And so the conversation gets a little complicated once you start digging into the details. But anyway, for us, we try to keep it simple, and you'll see later today I have a simple slide that lays it out.
So software only.
That's my point of view, yeah.
And maybe some other stuff.
But you have to keep this in a business perspective too. Take a look at the industry. So where's the money? Where's the margins for the people that are building it out? You're a software play, or a hardware. We do both. So you think a look at it's like the car industry right now. The car industry is the same problem. They're saying, well, do we just make boxes, or do we then move up the stack and take over control of the IP infrastructure?
Yeah, Ford just announced they're going to be a transportation company, not a car company anymore.
Exactly. So we really need to do the same thing from a vendor perspective, and we are. So there's other people out there trying to define what SDS is. Well, we're doing it. We got a platform, we got software, and it all works together. So we're trying to move upstream and bring the rest of the people in with us.
Yeah, I think that's what we've seen is software defined is definitely in the eye of the beholder. There's a lot of people with different interpretations, but predominantly what we see is most of your value is coming from the software stack, and you can run that software on your own private hardware for certain latency and performance experiences, and you can run that in white box, and then you can run that software in cloud. And then that data management should be exactly the same wherever you want to run it, and all your integration.
Okay, so the value is in software, and you can run it where you want.
Exactly.
Mm-hmm. Okay. Software-defined storage. Anybody?
By the way, thumbs up on that.
All right.
I don't care. It lives on hardware, and
That's it. Yeah.
I have a feeling that storage is always going to involve hardware.
There has to be some hardware somewhere.
Could be, yeah.
So the software really is the mediator, and there's lots of different bits of software in the entire stack. Like Flash itself is magic, because like if you actually find out how Flash works, I was talking to some guys from SanDisk once, and one of their engineers just made my mind explode. Flash shouldn't work most of the time, particularly when you get to like whatever it is, the 4-cell thingo. It's insane. You know, electrons are trapped inside this little thing, and sometimes they escape. So you have to do really complicated maths to figure out whether there are actually electrons in the cell or not. And there's software in the chip stuff itself to do all of that. So it's turtles all the way down, right? And there's software at every layer. The software exists there to make the hardware accessible and usable. And I think what we're seeing now, hopefully, is another layer of intermediation being inserted in there, another layer of abstraction away from the weird physics that's going on to make it usable, so that I can just say, you know, copy file from there to there, and then the software magically makes it all happen, and then I can go and look at it later and it's still there.
So what's the ultimate game for software-defined?
And that's, you know, I agree. I feel like, to me, I would like software-defined storage to mean storage that's glued to the things above it, storage that's attached to it in ways that make it do things that storage couldn't do before.
And I think, again, the magical thing that I want to have as someone who writes an application, I want to have it just go, I want some storage, and it has all of the characteristics that I like from storage. So it's permanent. I can go back to a previous version of it earlier. It never dies because of physical stuff happens, but none of that really matters because of all of the data protection stuff that goes on, and all of those features that I have about some storage just is there, and I don't have to care about anything underneath it. That for me is sort of the ultimate software goal.
We have a comment here, Chris.
Yeah, all of the discussions so far we've talked about platforms that data onto, and we talked a little bit about the inertia issue, the fact that to move stuff around is quite difficult. But nobody's talked about anything about moving the application to the storage and running the application on the storage so that you're not moving the data around. What are you doing to fix that issue?
Okay, so can we move the applications to the storage?
Bearing in mind you have software defined, and you have the ability to run any software you like on your box, how much are you doing towards the application to the data?
You want to start, Dennis?
Sure. So before I came with Violin, I was with EMC, working basically, we were talking about commuting back and forth to Hopkinton. So there was so much power in the beta storage processors in the front end of the VMAX, VNX, that wasn't being utilized. We actually, I was also working with Microsoft. We were looking at pulling part of the MS SQL, Microsoft SQL database, transactional processing into what you're talking about, right into the service processors on the storage array. So in our particular case, as an example, we have a set of Haswell processors in our gateways, our storage processors and our arrays. Very powerful. Don't use a lot of, we use a lot of it sometimes, but a lot of time we don't. So the question is, what do you do with that? So the industry is looking at how do you bring that back down into, how do you bring some of that processing into the storage array? But by doing so, you really have to have the cooperation of the application vendors. Because, you know, in the storage market, the heaviest users are database users and, of course, big data. How do you get them to work with you so that we can actually make that happen, have some methodology for doing that?
Yeah, I think the trade-off has always been as you put the data closer to the processors tend to get upgraded very, very frequently. So I think you like the idea of particularly 3D crosspoint very, very close to the processors, especially where those 7 microsecond latencies can really be used. But I think the bigger challenge is going to be how do you get the storage to scale that close to it? And you can use technologies like NVMe attachments and InfiniBand, really, really low latency networks to it. But I think ultimately you're going to have, if you run the compute and the storage in the same chassis, then they're going to be too tied together. What if I want to just upgrade compute? What if I just want to upgrade memory? So I think that trade-off is probably still going to continue with us even when we get 3D crosspoint. because you're probably not going to want everything. But I think ultimately we're going to need to pick, you know, a boundary there. I think some people hyperconverge, for example. There are options of using hyperconverge to run very, very close to that compute layer. But there's also the option of maybe doing very, very close to compute. 3D Crosspoint as local cache for it. So, you know, we've got R&D working on all the different flavors of it. But I think as 3D Crosspoint really gets cost effective and comes out into the market, I think that's going to drive the change.
So is part of the problem there that you're not advancing on the access to data in a format that makes it more transportable, more compacted. So the idea of things like vVols was to allow you to have a virtual machine that can be moved around and you can do stuff with. And really that hasn't delivered anything at all, really. It hasn't allowed us to pick up a VM and say, I'll push it to somewhere else or I'll do something else. Is part of the problem the fact that we're not moving on our data protocols to actually manipulate our data in a more efficient fashion?
I think the biggest liability right now is the applications. Most of the applications today aren't designed to be moved. You know, our Oracles and our SQL certainly can't. We're starting to see the second generations, the MongoDBs and things like that, the newer generation architectures. I think as applications are written to take advantage of these capabilities, particularly on-prem to on-cloud and back, I think that's where we'll see things where maybe they can trade memory and trade capacity between them. That's going to get a lot closer. In terms of converging the memory with the compute layer, though, for software-defined, getting things closer together, I think the 3D Crosspoints are going to push us there because that's where we're going to get the latencies.
Yeah, I'm pretty excited about that too. Yeah, we do have to wrap up here. Eric, did you have anything else that you'd like to add?
No, I do think that we're sort of in this mode where we're pushing toward new applications, and then we're still kind of a foot in the old world.
Yeah.
So you talked about, I don't want to think about my storage, just give me something, and we're getting there. But for those reasons, all of us still support iSCSI and NFS and all that stuff because we're trying to drag my old stuff along to the new. But we're, you know, I think, tooling for those new applications so that we can achieve things like Chris was asking for, just data movement along with application movement. So
I think that's going to be the biggest challenge.
Watch this space kind of thing.
Is, you know, storage is a very conservative space, and it has to be because of the lifespan, because of the inertia of data, because of the difficulty, and frankly, as Chris points out as well, because the protocols are ancient in computer terms. I mean, you know, pretty much the only new protocol is S3, at least the only one that people are really using. And so, you know, we can talk about all flash and we can talk about software-defined storage and the transformation, but we're not there yet, and so it pays to continue to support the legacy. So I do have to wrap it up. Thank you very much, panel. Thank you very much, audience. And I guess that's that, right, Enrico? All right, great.